Okay, geometry fans, today's lesson here is going to be another one about angles, and this is going to be our last discussion of angles in arc measure. We're going to talk about what happens when the angle is outside the circle. Well, the first thing though, before we get to that, is I want to tell you your geometry joke for the day. The question is, what do you call a man who spends a long time at the beach? And the answer is a tangent. Tangent. There we go. Beautiful jokes. Okay, let's summarize what we've talked about so far. When you have a central angle, if the vertex is at the center, then that angle measure is the same as the measure of the arc. And on the side here, as an example, if we have a circle, let's say that the center, we'll call it x degrees, and the arc measure is 72 degrees, then you know, let me zoom in a little bit here, then you know that x is equal to 72. If the vertex of the angle is on the circle, it is half the measure of the arc. So another circle. Let's make the angle now inscribed. So now the vertex is on the circle, and let's say the arc measure is 72 degrees, and x is the angle measure there. When you trace out the angle, the vertex is on the circle. If I trace this out, it hits the circle here and here. There's the arc. So the central angle, or if the vertex is on the circle, it's half the arc. 72 divided by 2 is 36. That is the value for x. And then the last lesson, we talked about what happens when the angle is somewhere on the inside. And what we said was that it is the average of the two arcs. So for example, we'll draw the circle. Those are two chords that intersect. And let's go ahead and call this x degrees. Let's say that this is 150 degrees. Let's say that this is 62. Now, the x degrees, the vertex is somewhere inside the circle, and if I trace out where x is, this angle, it's going to intercept the 150 degrees, and then the vertical angle is going to intercept 62. So when we calculate this, if the vertex is on somewhere inside the circle, then the angle is the average of the two arcs. 62 plus 150 divided by 2. And then we simplify this. We get 212 divided by 2, which is 106 degrees. That's equal to x. So we have central angle is the same as the arc measure. On the circle is 1/2 the arc measure. Somewhere inside is average. Now the other thing is, remember that an average is you just take a number, come over here, it's a number plus another number divided by 2. If you average two numbers, all you do is you add them up and divide by 2. The question is, what happens when the angle is outside the circle, when the vertex is outside? Now we're going to draw this and we're going to prove this relationship as well. So let's take a circle and let's draw two secants. Now remember, a secant intersects a circle in two places. Let's call the angle here x degrees. Now one thing that you'll notice about this is that when the secants intersect the circle, they intersect in two places. That's what it means to be a secant. Let's label the points here. The vertex, let's call that A, and then here's B, C, and then we'll put D and E here and here. Okay, now one thing I want you to notice, just like with the angle inside, notice that this outside angle, this exterior angle, creates two arcs. It creates BD and it creates CE. BD is smaller, CE is bigger. Now, this x degrees here, we're going to prove this in a similar way to what we did yesterday, or the last lesson with the inside angle. If I connect B to E, Now what that does is that creates a triangle ABE. Let me label angle CBE. Let me call this here angle 1. And then angle BEA, let me call that angle 2. Now, by labeling these the way we have, in the triangle, x degrees, angle 2, those are interior angles of the triangle. Angle 1 is exterior. And one thing that we know is that the exterior angle always equals the sum of the other two. Angle 1 is equal to x plus angle 2. The exterior angle is equal to the sum of the two remote interior angles. Okay, now let's go ahead and solve this for x. I'm going to subtract angle 2. So what we get here is angle 1 minus angle 2 is going to give you the value of x. Okay? Now angle 1, where's angle 1? Well, the vertex is B on the circle. If it's on the circle, it's half the measure of the arc. So angle 1 is half the measure of arc CE. And then angle 2, the vertex is here at point E. That's an inscribed angle, and that intercepts arc BD. If the vertex is on the circle, then the angle measure is half of the arc. So that's half arc BD. That gives you x. Now I'm going to clean this up here. Let me factor out the 1/2. What we end up getting is that the outside angle x is arc CE minus arc BD divided by 2. So yesterday, with the angle inside, you add the arcs and divide by 2. You take the average. But if the angle is outside, we're going to subtract the arcs and divide by 2. Now the way that I label this, I don't write that as the formula. The two arcs, I say CE, that is the big arc. CE is the big arc. And BD, okay, I'm going to call that the little arc. We have the big arc, we have the little arc. So the big arc is CE, the little arc is BD, so the relationship is we subtract them. Outside angle, we take the big arc minus the little arc, and we divide by 2. That is the relationship. Central angle is the same as the arc measure. Vertex on the circle, it's half the arc measure. If the vertex is inside the circle, it is the average of the two arcs. Outside the circle is the big arc minus the little arc divided by 2. Now, how do you remember all this? Well, one thing you can do, it's kind of like the slope formula, you can sing it. You can sing it to the tune if you're happy and you know it. So here's how it goes. If it's a central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. If the angle's on the outside, then it's big minus little over 2. All right, now let me do that again, but let me do that a little bit slower. If it's a central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. If the angle's on the outside, then it's big minus little over 2. And that's the relationship every time. That's always what it is. Okay, so for examples, first thing we want to do, number 1, find x. Well, where's x? X is this angle. The vertex is outside the circle. Notice that when you trace the angle, when you trace it, it's going to create the big arc at 146 and the little arc at 58. Now the outside angle, x, is we take the big arc minus the little arc divided by 2. When you simplify, subtract first. 146 minus 58, that is 88 degrees. Divide by 2, and we get x equals 44. That's it. In example number 2, find x. Where's x? It's this angle measure here. The vertex is outside the circle. Outside angle is we take the big arc minus the little arc divided by 2. So x equals 110 minus 42 all over 2. We're going to simplify that, subtract that. We get 68 over 2. X equals 34. And then example number 3. Again, we want to find x. X is outside the circle, so it's the big arc minus the little arc. Uh-oh, we've got a problem this time. Right now, we don't know what the big arc is. It's missing. However, we do know that all the arc measures of a circle always add up to 360, and they give us 91, 75, and 100. Well, let's take 91 plus 75 plus 100. We get 266 degrees. To find out what's left over, we need to subtract that from 360. So 360 minus 266, and what we get is 94 degrees. That's your big arc. So outside angle, x equals big arc minus little arc divided by 2. That's 19 divided by 2. We're going to get a decimal. We get 9.5. That's okay. It works. And that is the answer to number 3. All right, that is the end of side 1. Go ahead and flip it over to side 2, and we'll look at the other examples.